Question number 6 says to find the value of each of the following. So this question is a little different from the other ones in that we're using an inverse. We're going to try and evaluate these two, the little -1 and the exponents there indicate that we're finding an inverse. So just a review of inverses. When you're finding inverses of trig functions, it's important that you're going to only get one solution. So unlike when we use our unit circle to solve an equation where you're going to get two solutions on the unit circle and then add 2 pi k or pi k that would give you infinite solutions, when you're doing an inverse, you're going to only pick one. So imagine you're putting this into your calculator. Your calculator is just going to give you one solution. So you're going to think, well, how's the calculator going to pick which one it's going to give me? And so there's some kind of guidelines that you're going to use to pick your inverse, and mathematicians had to agree on this so that we're all picking the same one, because if we all pick different ones, it's not going to go so well. So the key is you're going to pick one, you're going to pick the one that's closest to 0, and you're going to stay positive if possible. So we'll talk a little bit about that more specifically now as we look at these. So the first one, we're saying cosine is going to be, we're doing the inverse cosine of -1/2. So cosine is the x value. So on your unit circle, it's going to be, you're going to have an x value of -1 in those two positions. But if you're finding the inverse, you're going to follow these rules and you're going to pick the one closest to 0. So one could argue that both of those are actually the same distance away from 0. But then the next one says stay positive if possible. So you're going to pick this one right here. So anytime you're doing the inverse cosine, you're going to pick, if it's positive, it would be in the first quadrant. If it's negative, it's going to be in the second quadrant. So in this case, that would be the value 2 pi over 3. If we're doing tangent, we're doing the inverse tangent of -1. Well, tangent is going to be negative either in the second quadrant or the fourth quadrant, and it's going to be -1 when the reference angle would be pi over 4. So it's going to be either 3 pi over 4, 7 pi over 4, those two spots. Again, we're going to just pick one, and we're going to pick the one closest to 0. So the one closest to 0 is certainly this one right here. So if you're doing inverse tangent, if it's positive, it'll be in the first quadrant. If it's negative, it's going to be in the fourth quadrant always. And so this one gets a little bit tricky, because if you're going to go to that angle, you could go this way, or you could also go that way. So you want to think, well, which one is closest to 0? And it would certainly if you went this way. So we're going to write this as -pi over 4. So once we've picked this one, then you're not going to worry about that third bullet, because being closest to 0 is the one that's most important. So you're going to pick this one here, and that's going to be -pi over 4. If you were doing the inverse of a sine function, then it would also, your two solutions would be either in the first or the fourth quadrant, depending if they're positive or negative. So once we've evaluated those inverses, now it's time to actually add them together. They're fractions, so you're going to need a common denominator. So I'm going to multiply the first one by 4 over 4, the second one by 3 over 3, and that's going to give me 8 pi over 12 plus -3 pi over 12. And if we add those together, you're going to get 5 pi over 12, which is your final answer.